Welcome, my name is Terry Soul, and this is Programming Chaos, a channel devoted to fun and interesting projects to help you hone your programming skills. For today's project, I'm going to be implementing FABRIK. FABRIK is an inverse kinematics algorithm that is used for procedural animation. So you can use it to animate, for example, limbs, or things like fish or snakes, any creature, if you will, with a flexible body. So the two nice features of FABRIK are, one, it's extremely flexible. You can use it for lots of different applications. And two, as you'll see, it's fairly simple to code. The name FABRIK comes from forward and backwards reaching inverse kinematics. So the basic idea behind the algorithm is there is a forward step in which we reach for an object. And in the process, as you'll see in a minute, we tend to dislocate the shoulder. And so then there is a backward step in which we reconnect the shoulder. So let me illustrate exactly how that works. So here I have a limb. It consists of a series of joints, and then between each joint there is a limb segment. And I know the length that those segments should be. So in the code, each segment has a defined length. And what I want to do is make this limb reach towards some sort of a target. I'll just use the mouse as the target. So it's going to reach down here for the mouse. And the first step is the forward reaching part. And that simply says, take the end effector, the last joint, and move it to the target. So there we've moved it to the target. In the process, of course, we've stretched out that limb segment way too much. And so now what I'm going to do is take the next joint, slide it along that line so it's the right distance away. So there you see that it moved. And of course, moving that joint has now overly stretched the one before it. So I'll move the next joint and the next one and the next one. And you can see we're now getting a much better curve here. The problem is, when I move the last one, I've basically dislocated the shoulder, right? It's no longer rooted the way it should be. And so now I'm going to take that exact same algorithm, but reverse it. And I'm going to take the last joint, and move it back to the right root location. I'm going to reconnect the shoulder, if you will. So there we go. And then that again stretches each limb segment. So I'll move the joints back. And now I'm missing the target by a little bit. And so I'll repeat the forward part of the process. There we go. Now it's slightly dislocated. So now I'll do the backwards part. And what happens after a few iterations is we basically reach a stable point where we've more or less reach the target. There's a little bit of error, and how much error you have depends on how many times you iterate this whole process. I've been slowing it down, but of course it happens very quickly in the background. And so effectively it just reaches and to the target almost instantaneously. There's one other thing I want to illustrate as long as we've got this example here. Let's say I put my target up here. So again, reach out and grab it, and then adjust each of the remaining joints. And of course, the shoulder now becomes seriously dislocated. So we do the backwards reaching algorithm and reconnect everything. And when we finish the backwards part, we're now very far from the target, but we have to be because the limb isn't long enough to reach it. So one of the things that's critical to understand is you always do an entire forward-reaching iteration and then the backwards-reaching iteration, and that's where you would stop. You might do both of them several times in a row to get closer to the target, but you always stop at the end of the backward-reaching part of the algorithm. And if I were to reiterate this a few times, you can see it becomes closer and closer to a straight line, because that's the way to get closest, is just to reach out for that object. But I definitely want to stop at this point after I've finished an entire backwards reaching portion of the algorithm. It also means that if you want to stop looping, you want to stop when between one iteration and the next, the end effector, this end effector hasn't moved very far. That means the algorithm is stabilized and you're done. Okay? Now, in terms of writing the code, there's a couple of pieces that I'm going to want. I'm going to create an object that represents the end effector, And I'm going to treat each of these joints as if they were also an end effector. Technically, in robotics, the end effector is whatever is at the end. It's the grabby claw. But the way the algorithm works, as we've seen, I'm going to treat each joint in succession as if it was the end effector and had to move to a particular point. And all that means is that my class, I'm going to call it end effector, even though maybe it'd be a little better to call it joint. Once I have an end effector object, then I'm going to create a limb object, which is simply an array list of those end effectors. And then I'll write the FABRIK algorithm to actually adjust all of those positions so that we get the movement that we want. So that'll make a little more sense once we start doing the coding. But the two big pieces are an object for each of the limb segments, which I'll call end effectors, and then an object which contains an array list to represent a whole limb. And the nice thing about doing it that way is if you want to create multiple limbs, it's easy because they're just separate objects. And you can say, I want limb 1, 2, 3. No problem. So let's start the coding. I'm going to program this in the processing environment using Java. And for processing, you usually have some boilerplate. There's a setup function and a draw function. Setup, in this case, will set up our window for us, and then draw as a continual loop that updates the screen. The first thing that I want, as I said, is to define my end effector class. So I'm going to create a new tab to do that in. So there's my end effector class, and I need to know the position really of the center of the joint and the length of the limb associated with it. So the position I'll represent as a p vector, which is just a two-dimensional vector that says here's where the joint is, and I need to know the length of the limb. And then I need a constructor to construct new end effectors. So in creating an end effector, I'll pass in the location, and I'll make a new p vector out of that xy location, and then I'd simply need to set the length. And that's actually all I need for my end effector. The next thing that I need is my limb class, which will be a whole array of these. So let's do another new tab, and we'll create our class. The first thing we need in the class is that array list. And I'll call mine segments because it's the different segments of the limb. So this is going to store all of those limb segments. And then it might be nice to know how many segments we have. I'm going to call this, I guess, number of effectors. And I'll start with 8. One thing to keep in mind is the actual number of limb segments is going to be 1 less than that because we have sort of a joint, i.e. an effector, at both the shoulder and at the hand. And so the number of segments in the middle will be 1 less than this. And then the other thing that a limb needs to know is both the target that it's reaching for and the route where it should be connected, which is sort of the opposite target, the backward target, if you will. And I'm going to make both of those p vectors. So one for the target and one for the shoulder. Now we need our constructor. And for the constructor, I'm going to pass in the root as r, but not the target, because the target is going to be continuously changing as the limb is moving around. The shoulder is fixed, so I'll make that part of the constructor. And then I want to make some varied limb segments, so I'll put in a little code for that. Basically, my first limb segment is going to be 200 long. And I'm going to keep track of each segment as I go so that when I first construct the limb, it'll sort of be the right length. Doesn't matter too much because as soon as we implement the FABRIK algorithm, it's going to move anyway. I think it's a little nicer to set it up so that it's the right length right from the start. And so now we just do a for loop to create all of those segments. So here we go. I'm adding to my segments array list a new end effector. And for each end effector, I have to give it the position of that end effector or that joint. And I'm going to set it as width divided by 2. So that's actually the middle of the window. And then height is the height of the window. So that's actually the bottom of the window. And I'm going to subtract from that the sum. So I'm going to move each of those joint locations starting at the bottom of the window. And I'm going to put the next one up a little higher and a little higher and a little higher. And then I also have to tell it how long each segment is. And so the sum, I add the limb segment to it. So I'm keeping track of where the next joint should go. And I want them to get a little shorter as I go just for interest. So I'm going to multiply by 0.8. So each successive limb will be 80% of the previous limb's length, or 20% shorter, if you will. And there we go. That should create all of my limbs, except that should be LS for limb segment. So this will now create a limb as a series of segments as long as I tell it where that limb should be rooted. And the next thing I'll do is just put in a little display function so that we can see this. It won't move yet, of course, but it's always nice to be able to see what we've done and make sure it's working. So this just says that I'm going to draw my lines in black, and I'm going to make the weight of those lines pretty heavy so they'll show up nicely on the screen. And then I need 2 p-vectors, i.e. 2 positions on the screen, one for the current joint or the current effector, and one for the next, hence the C in the end, because I'm going to draw a line between them. And I'm going to start, if you will, at the shoulder joint. So my current segment is going to be the 0th segment, and I just need to know its position. So out of my segments array, I'm going to get the 0th one, the shoulder joint, and I'm going to get its position, and that will become my current position. And in fact, right off the bat, I want to draw a circle there. And I'll make it a nice big circle. And now I simply need to loop through all of the rest of the segment. And as I loop through them, I'm going to get the current and the next position. So again, the current position and the next position, draw a line between them. And I'll put in some circles for my joints as well. So there we go. And that should be current.y, and segments does not have an E in it. So there, clean up the code a little bit. I'm drawing my first circle at the current location. All of the other circles are sort of drawn at the next location at the other end. And again, that just happens because I, in a sense, have one more joint than I have limb segments. But now I have the basic limb code, and so I can go in and create a limb. Just say that's limb L. I need to construct a new limb, and I need to give it the root location, which I'm just going to make the bottom of the screen. So this is the width of the window times 0.5, so the middle of the window, and height is the bottom of the window because processing's axes are sort of reversed. And so that's going to say the root for this limb should be at the bottom of the screen. And then in my draw loop, I want to draw it. First, I'm going to fill in the background with a medium gray, not that that matters for this all that much. And then I simply need to display my limb. And this won't be very exciting yet, but there we go. Although that is not as many segments as I would expect. So let's go back and take a look here. And the problem, which you may have already noticed, is down here when I'm drawing the circles, I'm doing NX, and that should be NY. And now if I run this, there we've got our limbs with all of the different length segments getting shorter as they go, and of course not moving because I don't have any of my actual inverse kinematics in yet. So let's add those. So the first thing I'm going to do is just put in a basic update function that will call both the forward part of the algorithm and then the backward part of the algorithm. So these don't exist yet, of course, but this will do the forward reaching part, and then this will do the backwards reaching part. And the reason I'm doing is two separate parts is so that we can do both the limb reaching that I talked about and also the snake or fish type motion. And to begin with, I'm actually going to comment out the backwards because I just want to write these one at a time. So let's put in our forward reaching component. And the first thing that we need to do is simply to get the last end effector, sort of the true end effector, and move it to the location of the target. So for reasons that will be clear in a minute, I'll call this next, and this is the last of the segments. That should be size. And there's a coding option here. I'm doing the size of the array of segments and then subtracting 1 from the size. That'll give me the last segment. I could also use my variable number of effectors, but there's always the chance, depending on what you're doing in your code, that the length of the limb has changed and that this is maybe not accurate anymore. So it's perhaps a little bit more reliable to just directly use the length of the array to grab that end effector. And then I simply need to set the position for that end effector to be a copy of the target p vector. So I have built into my limb, and I'll have to make sure that I set it, what the target is. And so here I'm simply making a copy of that p vector and making it the position of that last end effector. So this is the hand reaching out and grabbing the object, and in the process, stretching the wrist all out of shape. And now what I need to do is simply go starting at the end and working my way backwards and move each of the joints, each of the end effectors to the right location. So that's just going to be a for loop. And for this for loop, as I said, I'm starting at the end, but I'm starting at segment -2 because the last segment, the -1 segment, has already been moved to the location of the target. And then I'm going to go all the way back to the 0th segment. So I want to get, in a sense, the current segment, the current joint that I'm interested in, which is the ith one. And now I have to figure out where to move that. And the idea is I've taken the end effector, sort of the hand, and I've put it on the target. And my current joint is somewhere way far away. So I'm going to calculate the line between them, and then I'm going to shorten that line to be the length of the limb, and then I'm going to take where the hand is and subtract that from where the hand is, and that tells me where the next joint should be. Okay, so that might make a little more sense when I do it in code. So first I create a p vector called direction, and it is the difference, the subtraction of my next joint with the current joint subtracted from it. So think of the hand as the next joint and the wrist is the current joint. I'm now, by doing subtraction, I'm calculating the vector between those two. So I have the vector between them. And next I need to shorten it so that it's the correct length for the limb. So this is a nice built-in function that's part of the p vector class in processing. It's set magnitude. So I'm taking that vector, which is between my two current limbs, and I'm setting its magnitude to be the length of the current segment. And now that I have that length, what I wanted to do is take my next position, subtract that length from it, and that'll tell me where the joint should end up. So my current position should be equal to the p vector that I get by subtracting from the next position that direction vector. And so that takes the current joint and changes its position to be that difference. And then all I need to do is say next equals current. So what used to be the current one that I just moved becomes the next one, and the joint before that gets moved into this position. Hopefully that makes sense. That will do the forward reaching. So the last segment is moved onto the target, and then each segment before the last one, moving backwards, gets moved along the line to the right position, as we saw illustrated at the beginning. And of course, that will end up, as I said, sort of dislocating the shoulder. So now we need to put in the backwards reaching algorithm to sort of reconnect everything. And basically that looks a lot like this, but sort of in reverse. So I will uncomment it and go ahead and add it here. So there's my backwards reaching. And so I'm kind of reversing things. Instead of getting the last segment, now I'm getting the 0th segment, the shoulder. And I'm going to call that the previous instead of the next because I'm working backwards. And what I need to do with the shoulder is just set it equal to the root. So that reattaches the shoulder, if you will. And now I'm going to do a similar for loop. But this for loop counts in a positive direction because I'm working my way out to the end effector. And let's see, what did I mess up here? I misspelled segments as usual and also position. There we go. So again, I want to get the current segment, the segment that I want to adjust. And I'm basically just going to reverse the math that I did before. So subtract those two to find the vector between them, adjust the magnitude to be the right length. And the one thing that may look a little odd here is I'm using the previous length because the previous segment, for example, starts as the root, and the length of that first limb is based on the preceding joint. That is to say, the shoulder joint defines the length of this part of the arm. So that's why I'm using the previous length. And then I simply take this new direction and add it onto the previous position to get the current position. So the position of the current joint is equal to the position of the previous joint with the direction added onto it. And then previous equals current, and we're ready for the next loop. So if you compare them, you'll see that they're almost identical, just working in opposite directions. And so now I can go into my main loop and simply call the update function as long as I set the target. So I want to come in here. And I'll just do the same thing that I did in the example. I'll make my target the mouse location. And so I'll take the target of the limb and set that equal to that T. And I probably could have combined these into one command if I'd wanted. And then I simply have to add the limb to update itself. And assuming that I don't have any more typos or errors, this should be all it takes to get that limb to be animated. Let's see. Nope, I do indeed have an out of bounds error. So let's see. Oh, yes. I do this all the time. Probably you've already noticed it. I am counting backwards. If I want to count backwards, I actually have to decrement my eye. Let's take a look at that. There we go. And so I have a limb that nicely follows the mouse around. And that's all there is to it. It's doing the whole forward and backwards iteration, and it's doing it continuously in the background, but fast enough that it just looks like a nice, smooth motion. The one way that you can sort of see if you want a little bit of a disruption is if I move the mouse off one side of the window and carefully slide it around to the other, the limb immediately jumps over. And that's because the way that FABRIK works, it takes the last end effector and just sticks it on the target. So we don't have necessarily a smooth motion if the target does an enormous jump. But as long as the target moves continuously, so does the limb. There are no built-in issues here with collisions, so the limb can wrap back over itself. You can add a lot to this code in terms of things like avoiding collisions or calculating the angle of the limbs and putting a limit on those angles. But I think this works pretty well just the way it is. Okay, So there we have our inverse kinematics for controlling a limb, but I also promised that we could use this for doing procedural animation of sort of little creatures. So how do we do that? Well, turns out not too complicated. The first thing I'm going to do, though, is go into my limb and make them a lot shorter, because if I want a creature, I really don't want it to be that long. And then the second thing I'm going to do is go into my update function and comment out the backwards reaching part. And then I'm going to run it. And now we have, okay, it doesn't look entirely like a creature just because of the way that it's drawn, but without the backwards reaching part, it follows the target very nicely. So you were probably worried that we were going to have to do a whole bunch more code in order to get our nice swimming fish or wiggling snakes. Nope, we just removed the backwards reaching part, and there we go. We have a nice procedural animation for creatures as well, assuming, of course, that you update the way it's displayed. So you probably want larger segments and add some eyes and all of that. But this is the sort of perfect place to get you started on either doing limbs or procedural creatures. Excellent. Thank you for your time and happy coding.